In the next set of examples for graphing inequalities, we are now going to be working with inequalities that have two variables. Now, just because we change from one variable to two variable does not mean that the process changes. We're still going to go through our 4 steps. And in the process of doing this, we will end up creating an inequality, but this time without horizontal or vertical lines. So if you need a quick refresher, maybe go back to the previous lesson and review how to graph lines in slope-intercept form and review how to graph lines in standard form so that you will be comfortable doing the first step of the inequalities, which is graphing the actual line. Okay, I'm going to take you through example number 2, part A, and then I'll go through part B as well since it's a different form. And then you can work the examples after that. So let's take a look here first. In example number 2, the very first thing we have to do is we need to rewrite this as an equation of a boundary line. And so we're going to rewrite this as y equals 2x. Now, if you notice, we don't have anything added to the 2x, but if you want to make it easier to see the slope-intercept form, you could technically write plus 0. And then you could see the y equals mx plus b form. And of course, to graph this, I would just plot 0, 0, and I'd go up to over 1, or I could go down to and over 1, just like I learned how to graph a line in slope-intercept form. And now I need to draw the line, and I have to pay attention to whether I'm doing a dashed or a solid line. And since it's not equal to, it's going to be a dashed line, and so freehanding that the best I can. Now, we get to the third step, which is to test a point. And if you notice, in previous examples, we're always testing the point 0, 0 because it's easy to calculate. However, for this particular example, 0, 0 is actually going to be on the line. So we cannot use 0, 0 as a test point. That's not going to help us decide which side of the line to actually shade on. So I'm going to just pick a random point on either side of the line that's not on the line. And of course, this example uses 1, 1. Now, here's the second point about testing in two variables. We need to know which one of the variables actually represents an x and a y, which value represents x and y, and so I can plug this into the inequality. And through this process, I get the value 1 is less than 2, which is a true statement, and so that means that 1, 1 lies in the shaded area because it would lie in the area on the side of the graph that has all of the solutions, and since it's a true statement, it's considered a solution. And then we would simply come in here and graph, shade in all the parts on that side of the line. So you can see that the process here is exactly the same as it was before. Now we're just dealing with more complicated lines. Now, part B has us in standard form. So if you recall standard form, first thing we need to do is change this to a line, and we need to graph this line. Now, you could graph this line by the use of slope-intercept. You could move everything to one side and get y equals, or you could use the x-intercept and y-intercept, and so you could t-chart a value 0 of x, and you could t-chart a value 0 for y, and in the process of doing that, you're going to get the point negative 2, and then you're also going to get 5, 0, and you can see here we would plot that point and plot that point, and of course it's equal to, so we're dealing with a solid line, and so we would graph that line right there. And again, we need to test the point. This time, however, 0, 0 is not on the line, so I could test the point 0, 0, and I'm going to do that by replacing the x and the y value with 0, and so anything times 0 is just 0. So is 0 greater than or equal to 10? we know that that is a false statement. And so since 0, 0 is right here, none of this would be shaded. We're going to shade everything on the opposite side of the line from 0, 0. And so that's just two quick examples of how to graph inequalities with two variables, one in slope-intercept, one in standard form. Now, some of you are probably holding on to your calculator thinking to yourself, how can I use this thing? So let's see how we can use this thing. I'm going to go to the calculator now to kind of finish up these examples and just test the calculator and make sure I get the same thing as what the example gave me. Now, go to the calculator and go on into your graphing screen. And you're going to notice here we have f of x, which we know that means just the same thing as y. But we have an equal sign, and the equal sign actually needs to be changed to an inequality. So the way that we do this is once we have an input here, I'm going to actually backspace or hit delete. And when you hit delete, you're going to notice that it's actually going to give you 5 different options. Number 3 was the equal sign. We already had that. So I'm going to use less than, but not equal to. So that's important. And then I'm going to hit to x, and I'm going to simply hit enter. Now, what you're going to notice is it shades it, and you can see very clearly the dotted part of the graph, or the dash part of the graph. So that's a nifty little tool to just verify everything that you did correctly. Okay? And trust me when I tell you, this will make life on the ACT a lot easier if you just want to graph this real quick without having to go through the entire process of testing points and everything like that. So that is the examples for two variable inequalities. Now what I'd like you to do is to go ahead and move on down to sample problem number 2, part A and B. And I'd like you to go ahead and stop the video at this point and work those two problems. And you can come back in the next video and watch the solutions to those two problems.